Hi students, MCQ number 5. By what factor does the RMS velocity change if the temperature of a gas is raised from 27 degrees Celsius to 327 degrees Celsius? So here only one gas has to be considered at different temperatures. So I will take the temperature T1. Okay, T1 is equal to 27 degree Celsius. So the proportionate value in absolute scale is capital T1. So this is equal to 27 plus 273 Kelvin. This is equal to 300 K. Similarly, T2, this is equal to 327 degrees Celsius. So convert it into absolute scale of temperature. So this is 327 plus 273 in Kelvin. So this is equal to 600 K. So the temperature is twice as 300. Now what is to be found? By what factor does the RMS velocity change? So we have many times gone through this expression that Vrms is proportional to the square root of the absolute temperature. Isn't it? So in the first case, I will take the RMS velocity as V1. In the second case, I will take it as V2. So I will write V1, Vrms 1 is proportional to square root of T1, and Vrms 2 is proportional to square root of T2. So V1 by V2 is now equal to square root of T1 divided by T2. So now we substitute for T1 as what? 300 K. So this is 300 divided by 600. So this is equal to square root of 1 by 2. So V1 by V2 is equal to square root of 1 by 2. Therefore, V2 by V1 is equal to square root of 2 divided by 1, or V2 is equal to root 2 times the V1. This is what is required in this problem. By what factor does the RMS velocity change? So it is increasing by a factor of a square root of 2. Okay. Therefore, option B is the correct answer. So, what is the basic equation required here is we have to remember. We have to remember that the RMS velocity is given by square root of 3kt by small m, or this is equal to square root of 3rt by capital M. In both the cases, Vrms is proportional to square root of the temperature. So from this we have solved this problem. I hope you must have understood this well. Fine.